This is the day one video over linear inequalities. This section starts out very similar to our linear equation unit. So the first thing that we have here, it says to determine which ordered pairs are solutions to the linear inequality 2x minus 3y is less than 15. So the first thing that I'd like to do is talk about how a linear inequality is a little bit different than a linear equation. So in a linear equation, we have an equal sign, which means that the solutions are going to be equal. When you have the inequality, that's when you're going to have that less than, greater than or equal to, or less than or equal to. So that opens up our solution set to be much larger, okay? But if I'm given an ordered pair and I'm trying to determine if it's a solution, we're going to use that ordered pair the same way we've used it all throughout this year. So I know that ordered pairs are written with x first and y second. So if I'm trying to tell if something is a solution, all I have to do is substitute it in and see if it works. For example, here I have 2 times 2 minus 3 times 5, and I want to know, is that less than 15? Well, 2 times 2 is 4. And 3 times 5 is 15, and 4 minus 15 is equal to negative 11. So the question is negative 11 less than 15? And of course, we know that that's true, so I know that this ordered pair is part of the solution to this inequality. Now, with an inequality, it's not just going to be one solution. There could be multiple solutions. So I'm going to use that same process on these other ordered pairs. So I'm going to do 2 times 3 minus 3 times negative 4, and I'm going to see, is that less than 15? So 2 times 3 is 6, and then I'm doing negative 3 times negative 4, and then when I combine those, I get 18. So 18 is not less than 15, so I know that this is not part of my solution. Why don't you see if you can go ahead and plug in and see if negative 1, negative 7 is part of our solution set, and if 0, 0 is part of the solution set. Go ahead and pause the video and do that now, and then you can check your work with mine. So whenever you substitute in negative 1, negative 7, and you do the computation, you get 19. 19 is not less than 15. That's why I crossed this out. It is not part of my solution. When I plug in 0, 0, however, I get 0 is less than 15, which is true, and that is why I circled this one, because it is part of our solution set. So I have two ordered pairs that I know will satisfy this linear inequality, and I have two that do not. So today in class we talked about how to graph a linear inequality, and what you should notice is initially the graphing is very similar to graphing a linear equation. We used slope-intercept form, so notice y is alone on the left, and then I have the mx plus b on the right. And then we're going to follow these 3 steps. Okay, so the first thing I'm going to do, as I said, is make sure that it's in slope-intercept form. That's going to allow me to graph my y-intercept and use my slope to find another point. So let's go ahead and graph that first. So as a review, you guys should be aware at this point that b, which is the y-intercept, negative 4, is going to be the first point that I plot on my coordinate plane. Once you put a point on your y-intercept, the next thing you want to do is you want to look at your slope, which in this case is 2. Remember, if it's 2, that's like 2 over 1. So from my y-intercept, I am going to rise 2 and run 1 and put another point. Okay, so I'm going to do that now. So this is where things change a little bit. So in the past, we would continue to rise 2 and run 1 and get as many points as we needed in order to make our line extend all the way across our coordinate plane. Well, now, instead of just drawing a line, I need to figure out, is my line dashed or is my line solid? So let's think about that. A dashed line would mean that the solutions, or the ordered pairs that fall on the line, would not be part of my solution set. That's like a boundary. So that's where the solutions begin, okay? If I have a less than or equal to or greater than or equal to, that's when I'm going to use that solid line that tells me, hey, all the ordered pairs that are on this line satisfy this inequality. So I notice here that my inequality is less than, so I am going to draw a dashed line. Remember to use a straight edge to help you make sure that your line is straight, to make my line go all the way across my coordinate plane. The last step here is to determine, do I shade above this line or below this line? Because remember, in an inequality, you're going to have multiple solutions. So it says to use a test point to determine which side of the line to shade. So if you think back to what we did on the previous slide, we plugged in ordered pairs. My suggestion is that you use 0, 0 as your test point, because that'll make it just a little bit easier to do in your head. So if I put a 0 in for x and a 0 in for y, that would be 0 is less than 2 times 0 minus 4. I would get 0 is less than negative 4. This is not true. Therefore, I know that I need to shade on the other side of my line. I know that the solutions for this inequality occur below the line. Another thing that I taught you guys, besides using your test point, is that if it's less than, if you put your pencil on your y-intercept and draw a line to, or an arrow to where the points, where the numbers are less than that, which would have been down here, then I know that my solutions fall underneath this line. Okay, that means that any ordered pair that falls in this shaded region would satisfy this inequality. Okay, since this is dashed, the ones that fall on the line are not part of my solution. So let's look at one that is not written in slope-intercept form. So the first thing I'm going to do is go ahead and put this in slope-intercept form by subtracting 5x from both sides. Once I do that, I'm going to bring down my negative 2y is less than or equal to negative 5x plus 12. The next step is to divide everything by negative 2. Now remember, when we did our inequality unit before, we learned that if you multiply or divide by a negative, you have to reverse your symbol. So I'm going to circle that so I don't forget, and I'm going to get y is greater than or equal. Negative 5 over negative 2 becomes positive 5 over 2x, and then 12 divided by negative 2 is negative 6. I have now completed step 1, and now I can begin graphing. So my y-intercept is negative 6, so I am going to put a point on negative 6. My slope is 5 over 2, so I'm going to rise 5 and run 2 and put a point. Then from there, I have to determine, is my line going to be dashed or is my line going to be solid? Notice right here, my inequality has the equal to under it, which means that I have a solid line passing through those points, and also tells me that all the points that fall on that line would be part of my solution. Then last, you can either choose a test point or do as I suggested in class. If I want greater than or equal to, I put my pencil on my y-intercept. The numbers greater than that would be up here, which means that my solutions fall above this line. So I shade in everything above the line. Had you chosen to do a test point of 0, 0, well, 0 is greater than or equal to 5 over 2 times 0 minus 6. Is 0 greater than or equal to negative 6? Yes, it is. And you notice that when we shaded on the side that contained 0, 0. So I know that my shading is correct if I use either method. We will be working on graphing linear inequalities a little bit more in class tomorrow, which means that you'll have a little bit more practice before we start systems of linear inequalities. However, if you have any questions, please come in for tutoring, and I will see you then. Have a great day.